Hi everyone, welcome to the session of Logistic Regression where I'll show you and also give you a reason why log transformation and why not. So if you can see in this slide, I have already shown in my session number 4 where how today while deriving the logistic regression we have applied the log transformation, but I have not explained why that was it. So if you see, this is my left hand side and this is right hand side, and this y is equal to mx plus c. So clearly if you see here, the because y being a binary, we are concerned with the logistic regression, so our output will be 0 or 1, and in the right hand side our value, the range of values that we can get is from minus infinity to plus infinity. Okay, now after this what we have done one more transformation. Instead of y we will go for a probability p. Okay, and here the probability p will lie between 0 and 1, and still this right hand side it will be y is equal to mx plus c, and still this will be the same minus infinity to plus infinity. Then after this, the step third, what we have done, we have tried using, instead of log we'll go for the odds. P by 1 minus p is equals to mx plus c. So p by 1 minus c, this, the range here will be from 0 to plus infinity, and my right hand side range will be minus infinity to plus infinity. Still it's not matching it. Then finally what we'll do, we'll apply a log transformation. Natural log p by 1 minus p is equals to mx plus c, and now the range will match minus infinity to plus infinity, and here also minus infinity to plus infinity. So while doing so, then you can solve, and finally you can say p by 1 minus p is equal to e to the power of mx plus c, and then finally you can derive p is equal to 1 by 1 plus e to the power of minus mx plus c. But this log transformation, how this is will help. Okay, so this is my agenda of this session. So suppose what we will do here, I'll say that suppose we know only a person height and we want to predict whether the person is a boy or a girl, okay, male or a female. And we can talk about the probability of being a male or female, or we can talk about the odds of being a male or female. Let's say the probability of being a female is 0.9. Okay, probability of being a female is 0.8. Odds of being a female will be probability of female by 1 minus probability of female, which is equals to 0.8 by 1 minus 0.8, and this is nothing but 4 by 1. The odds of being a female will be 4 by 1. Similarly, the probability of, if the probability of female is 0.8, then the probability of male will be 1 minus 0.8, which is 0.2, and the odds of being a male will be how much? Probability of male by 1 minus probability of male, and this will be 0.2 divided by 1 minus 0.2, and this will be 0.2 by 0.8, and this will be 1 by 4. So if you see here, this symmetry, okay, is not very convincing. What we will do, we'll apply logs. So if we apply logs to the natural log odd of female, okay, to the base e, which is nothing but log of 4 by 1 to the base e. Okay, so this will be log of 4 to the base e, and this is nothing but what we are finding the log of odds for female. Similarly, the log of odd for male will be log of 1 by 4 to the base e, and this can be termed as log of 4 to the power minus 1 to the base e, which is minus of log of 4 to the base. So you can see, if we apply the log, then the value is exactly similar, only a negative sign is there, and that will show how the symmetry will work. So we can finally say that the log of odds being a female is exactly opposite to the log of odds being a female, because in this case it is log 4 to the base e, and in this case is minus log 4 to the base e. So this is how we can say the log transformation is the best transformation for logistic regression. Let's just use Python and execute. Suppose we have our contingency table, and we have our like this is the table where we have the purchase gender for the both male and female, and we have the no and yes. This is my the same contingency table. Okay, this is our contingency table, and we will find out the probability of female buying the item and also the probability of male buying the items. Okay, so the probability of female buying the item will be 159 by this one. Okay, it's the sum of these one. So 159 by 280, and the probability of male buying the item will be 121 by 280. The odds of female buying the product or the item will be probability of female by 1 minus probability of the female, which is 159 by 280 divided by 1 minus 1 minus 159 by 280. Okay, this will be 159 by 280 divided by 121 by 280, and this will be 159 by 121. Now similarly the probability of male buying the item is 121 by 280, and the odds of male buying the item is probability of male by 1 minus probability of male, which is equals to 121 by 280 divided by 1 minus 121 by 280, and this is equals to 121 by 280 divided by 159 by 280. Okay, so if you see here, this is nothing but 121 by 159. Now 129 by 151 is exactly the reciprocal of this. So if you take the log of odds of probability of female, which will be equals to log of, okay, say natural log of 159 by 121 to the base e, and the log of odds for the male, which will be equals to log of, okay, how much, 121 by 159 to the base e, and this will be minus of log of 159 to the base e. Okay, so this value is exactly opposite of this. Even if you don't want to find, I'll show you mathematically, okay, using Python. Log of 159 by 121 to the base e and log of 121 by 159 to the base e. So we'll go to our Python this. So what we'll say, np dot log of 159 by 121, this is natural log only, so this value, and if we say the opposite, okay, 121 by 159, and it is exactly opposite to what this value, okay, this is negative of this one. So this is how the log transformation is used in the logistic regression, and I've shown you mathematically why we use log transformation. So thanks a lot for watching this session. If you feel this video is helpful, please press the like button and subscribe to this channel, and also please share my videos with your friends, and please post in the comment section if you need me to cover any other topic. So I'll see you in my next video. Thank you.